You might be asked to think about the percentage of each element in a substance. And when you're asked for this, you're talking about percentage of each element by mass, right? If I have 100 grams of water, how many grams of hydrogen do I have? How many grams of oxygen? Okay, so I picked a different compound, but so percentage composition, please remember percent, right? That's cent, like century, it's per 100. Okay, anytime you find a percent, you're looking at, so percentage is always some part divided by a whole thing times 100. The reason you're multiplying by 100 is that it is percent. If you were doing parts per million, you'd be doing this same fraction, part over whole, but instead of multiplying by 100, you'd be multiplying by a million. If you're doing parts per thousand, you're times 1,000. This is parts per 100. So, question, what is the percentage of carbon in sucrose? Well, this is the formula for sucrose. So what we need to do is calculate the molar mass, or the molecular mass. You can think in either way. You can't just count the atoms. So I wrote this, I want to point this out. You can't just say, oh, well, there's 12 carbon atoms and there's a certain total number of atoms. You need to account for the fact that carbon atoms weigh a different amount than hydrogen. And hydrogen weighs a different amount, right? It has a different mass than oxygen. So we find the masses. We say, okay, carbon makes up 144.12 out of the 342, and so on. So I'm writing a fraction here. The fraction I'm writing is a true statement. For every 342.30 grams of sucrose, there are 144.12 grams of carbon. So we just showed that. Now I'm multiplying that by 100. So part over whole times 100, but I've included the units here so you can really see why we're doing this, and that you can use this type of a conversion factor often in chemistry. So if we just notice what units cancel out, it is grams of sucrose. We are left with grams of carbon per that 100 grams of sucrose. All right, so sucrose, if you divide this and multiply by 100, you get 42.1% carbon. You should also come up with 6.5% hydrogen from this part over whole times 100, and you should come up with 51.4% oxygen. So just make sure you can do that.